whenever, let's say, the interest rate or the exchange rate changes, then they should be observable by all the accounts who actually share all the data. Okay, that's the first problem here. And the second one, this might be a little bit related to what you learned from 2031. Let's say you have different processes with different threads who are trying to access some semaphore, trying to access unlimited resources. You want to make sure whenever a single process or thread takes out the 1 unit from the resource should actually decrements. And then when you actually decrements to maybe 0, then no process can actually make progress until someone else actually releases the resource and increments the resource count, right? So that's the second problem you can actually solve. But you can see both are actually similar in the sense that you do want to have some shared objects. So just conceptually, let's say there's some shared objects. Some shared objects here, and then somehow you have different objects here that actually can get access to it. So that if you change the value in the shared objects, it will be visible to all the sharing parties. That's the basic idea. Very simple. Okay, let's see. So whenever we want to show you some design pattern, let's see what a bad design is. Let's say this is how we do this is how we solve the first problem here for the shared data among bank accounts. Let's say this is how we do it. Let's say we have a single class called shared data here. We have interest rate, we have exchange rate, we have minimum balance, we have maximum balance, and then we simply let, so inherits, we are going to talk about it actually later today, but inherits like an extend in Java. We simply say we want to make these data available to all the individual classes here, like for deposit, for withdrawal, for account, etc. So each one of them, because they actually inherit from this shared data, they're going to inherit the fields over here. Okay, that's one possible design. What are the problems here? Remember, the problems we are trying to solve is to have some shared set of data. And we do have some shared set of data. Let's say interest rate, exchange rate. But what's the problem here? Apparently, at the runtime, we can instantiate many objects from this deposit. We can also instantiate many objects for withdrawal and also many objects for accounts. And let's say, in the case where, let's say, interest rate, exchange rate, minimum balance, maximum balance are constants, let's say. If they are constant, let's say they never change in this assumed scenario, then will this be okay? So because each object will actually get a copy of the shared data, since they never change, so that should be okay. Any problem with that? Okay, so the problem with that, any idea? You can just speak that out, that's okay. Don't worry about it, that's right or wrong. Yes?
What if an account needs a different type of shared data? What if not all accounts have to have exactly this?
That's a good point, but let's say somehow, that's a very good point. What if, let's say the shared data includes all the possibility, all the data that you might ever need for the bank application? So, I think that's a very good question. That leads to one of my comments about this design. So let's say this shared data here actually contains a huge list of attributes, or a huge list of integer or constants, etc. Somehow, let's say for the deposit, somehow let's say you don't care about the exchange rate and interest rate. You only care about the minimum balance and maximum balance. So somehow you're inheriting something that's irrelevant to your current class. On the other hand, let's say for the account, you only care about the interest rate and the exchange rate. And again, you're inheriting something that's irrelevant to your current class. See my point? So let me draw the diagram here.
Yeah.
So let's say this is your shared data. Actually, you can also have a look at the diagram in the next slides. let's say this is a shared data. And somehow we contain so many data here to be shared among all the three. As I said before, somehow only part of it is relevant to the account. The other ones are irrelevant to it, although it will still inherit those data into the class. So that means at a runtime, if you think about it, so let's say we have ACC1 at a runtime, and somehow it actually contains so many fields here. So these are never used because they are real relevance from the class point of view. So they are somehow polluting your class. Okay, because well, basically to make it make the long statement short, in this design here, it is very possible that because the shared data has to be somehow complete to actually satisfy all the possible subclasses. So that means not necessarily each subclass will use all the shared data. In the case they don't have to use, they will still be there, available, but never used. Okay, that's one thing. So waste of memory space, and also something to do with cohesion. I'm pretty sure you heard about this term back in 10, 20 years ago, cohesion. So when you do your class design, cohesion is very important. Cohesion means you have to make sure you only group relevant features in a single class. You never include any irrelevant features in a single class. Okay, for example, let's say if I have a count here, it may not make sense for me to have a feature that we call sort, or to say to lend an airplane, etc. So, I choose some extreme case where it really certainly doesn't make sense. So the account class, you should only include the features that actually make sense to the name, because you're trying to achieve the purpose of serving some bank account. So you should never include any features that are actually irrelevant to the purpose of the class. Okay? So in this design here, it might work provided that the constants are, all the data are actually constants. So each object here is going to keep a separate copy of the complete set of data. However, from this design point of view, that's not good, because it violates the cohesion. It's a very bad cohesion for your design. You're simply including irrelevant details into your class. That's point number one, pollution of the class. The second point is the assumption that these data here don't change is unrealistic. Who told you that the exchange rate would never change? That would be very unrealistic. So let's say if each one of the accounts, let's say we have 2 accounts. So each one of them has a separate copy of the exchange rate. Initially, they might be the same. However, let's say at the end of the day, let's say exchange rate increases or decreases. If you want to actually update the exchange rate, you have to walk through all the objects and change their field for the exchange rate. That's simply not convenient. You want to simply have some single place where you can just modify once, and then you'll be shared by all the others. Okay, you can see the 2 problems. So from the design point of view, it simply violates the cohesion principle because it pollutes the class. And the second problem is it simply wouldn't work because if you have actually changed any of the shared data, you actually have to go to all the instantiated objects and change their data accordingly. Got a question? Yeah. Okay, that's good. Now, so sharing data, so it's actually exactly what I said here. And of course, the same design pattern here, the same bad design would not work for the second problem. It's actually even more obvious because you want to make sure the shared resources is actually going to be visible by all the sharing processes. Whenever you make a change to the share resource, it should be visible to all the objects, all of the processes or threads. Okay, so this actually goes, so now this will actually give us the some hints about what should be a good pattern for the design for these kind of problem, where you want to have shared resource. Okay, so now the solution, actually basically these are the principal ideas. So these are still independent of iPhone. Okay, so up to now we haven't talked about iPhone yet. So these are the two most important properties for the solution that we're going to propose. The first is, you can see that in the bad design, we are trying to encapsulate all the shared data in a single class. Okay, that's not good, as we already know. So now we can try to encapsulate something else. What we're going to encapsulate is not the data, but the access to the data. How we actually access to the data. That's something we want to encapsulate. We want to say, somehow we want to create some middle layer to say, somehow we want to have something there. So this is some encapsulation of the shared access. So all the objects is going to get access to here only. And then somehow this can actually changes the shared data. And we want to make sure this access object here is the only possible object you can have for the shared data.
Oh, so this means some file, if they only need three shared data, they use a class to access.
Yes.
To use the object.
Inheriting from that.
Oh.
So you can see that the difference is in the bad design, the irrelevant attributes will be inherited anyway. But in the good design, in the single design, you only use the attributes when you need it by using the access to access it. Okay, that's basically the motivation. So you can see this is the key. Instead of encapsulating the data, we want to encapsulate the shared access. Okay, that's really the key. Okay, so we're going to encapsulate shared access itself in a separate class. That's really the asset for single pattern. And once you learn the syntax, you're done with this pattern. Okay, so now to do this, we're going to introduce yet another new syntax in Python. You can think of the syntax here is similar to the static keyword in Java. So we are defining something that's global to all the objects that can be instantiated from the current class. So the keyword to learn is once. Okay? Remember when I talked about implementation today, so anything that's in between do and end is considering the implementation. So now, for this particular singleton pattern, you're going to change from do to once. So that's a new keyword you have to learn. Okay? If you just think about it, just for its literals, what does that mean? That means you're going to call that maybe multiple times, but the implementation body is only going to be executed once, only. And for the very first time it gets executed, the result is going to be cached globally. And later on, whenever you call the same routine again, only the cached result is returned, rather than recomputing the whole body. Okay, that's for the once. Do we have some question there somewhere? Okay, let's say for the first time, when I call R here, and then it's going to compute the body here, and then see what the results are, and then cache that somewhere globally. And later on, for the second time onwards, when I call R, you're just going to return back to me the cached result without recomputing the body again. Okay, so I said that actually also in very detailed in the slide. You can also read it over after lecture. So now, my question is, why do we bother using this once? So how does this help us? How does that help, really? So you can see that, so this is the general layout for the singleton pattern. So this is the axis, and that is the shared data, right? So somehow we want to make sure two things. One is, only the access data here, only this object here, only this one, can actually get access to shared data. Anything else must access the shared data through this object here. That's first point number one. Second point is we have to make sure we have only one single instance for this shared data. We don't have multiple instances. That's exactly the bad point. The bad points about the previous design. So two things. Okay, let me write it down. So the first is only the axis objects and the axis object here and
Excuse me. This means in the shared data class, there are only one object in the shared
There will
data.
be only one instance of the shared data.
So it means the one object in the.
Only one object, yes. Only one object at the runtime that's of type shared data. Okay? So for the second point, we're going to use the once routine. Okay? The one that I just introduced. Take a guess. How do we achieve the first point? How can we be sure that only this shared object here can access the shared data? Inheritance? Anything else?
The export with the curly braces?
Yeah, not inheritance actually. Inheritance is a bad design. Okay, anyway, thanks for trying. So the correct answer, as Chris just said, is to try to export the access of this shared data to only the access class. That's exactly what we're going to do. Okay, so that's basically about it. I'm going to show you some code and then we're done for this pattern. It's very easy. Okay, that's the architecture diagram. I think you have that already. So you can see that now we have a separation between the shared data here and also the data access. So this is the encapsulation here for the access itself. First of all, you can see that we have a client supplier here. So the data access can access the data here by calling data, because you can see data is of type data. You can see the once routine occurs in the access, which means whenever you call the data from elsewhere, it's only going to call it once and to make the instance only one time. And any subsequent calls to this data here will just return exactly the same data objects back to you. Okay? So you can see, let me improve this diagram a little bit. So make some notes here. So here, the way we access here is by calling the data objects. I know the date there might be a little bit confusing, but this is data. Also here, the link here, client supplier, it should be client supplier. Also data. Let me redraw this a little bit. It's important. So share data here. Okay. There's some class here. And that's client supplier. So that's why you have to draw it like that. It's not inheritance. Okay, so you have data access. Okay, so here, now you have here you have, let's say we have account. So you have account number 1, account number 2, account number 3. So all of them actually have some client supplier between themselves and also data access. That's called just maybe some attributes. I'll show you some code in the latest slide. That's called the access. So whenever account 1, they want to access the shared data. So here, this is data here. What they have to do is not by calling the data directly, because what they have to do is by calling the access first, and then from the access point, they can call the data. Because only from this point here, you can call the data. That's actually ensured by the export status. So let's have a look at here. So you can see the data here. We do have some restricted access here. You can see, so we say the make routine is only available to the data access. Okay? And also you can see the data here is actually defined as a once routine. So that means we're only going to create the data object only once. And later on, from the second call onwards, we're going to return exactly the same data objects. That's actually the semantics for the once routine. Okay? Yes, question?
Export is the instant on object.
Say that again? Oh, export. So you can see that over there, also on your diagram, this is the export status. So you're going to say this make feature here can only be called from the context of the data access class, but nothing else. remember before we actually had some extreme case. If you say here export status is none, that means it cannot be seen by any other classes. But now we are relaxing that export restriction here. We're saying only the data access class can access this main function here, but nothing else. Okay, so now let's see. We have more code to show you, and here you can see that the vertical line here, like a line crossing the client supplier here, that means expanded types. Okay, so we are making this data access class expanded. I'll show you why we want to do that. It's actually convenient to do that. Okay, so 2 points to notice. So we simply need a restricted data access here, and also we need the once routine, and we also need expanded routine, expanded classes. Those are the 3 things that are specific to iPhone in order to implement the singleton pattern. Okay, let's have a look at the code. Okay, so now this corresponds to this design here. So now let's say, again, from a supplier point of view, so now you can see that this is the shared data here, and this is the access. Okay, you can see that for the access, we declare that to be expanded, and here for the back data here, we are restricting the access of make. So 2 things we are restricting. We are saying you have to actually apply both. So we're trying to say, whenever you say create, you say local here, and then you say create. Actually, what? It's actually saying the code. By putting the bank data access here, you're saying you can only call the make feature from this class and nothing else. That means from the client side, you simply cannot declare something that's called data, and they simply say create data.make. You cannot do that. Okay? So now let me just write to you on the client side. If you want to say create, you can see we have some attribute here, which is called data here. If you want to say data.make, this would not compile. That's the thing we want to avoid. The only thing we are allowed to say is to say in the access class, we can say create result is of type bank data. So we can say create result.make. This is allowed because you can see the access here is only allowed in the bank data access.
Can I say it again? Can I say it again? I still don't understand.
Okay, so we're trying to say from the client's point of view, you can never make such a call to say create data.make. So this will actually create a new object of type bank data. And that's something we want to avoid. We want to create only one single instance of type bank data. So we never want to be in any single client's objects and to call the create data.make.
So this one is the shared data, or
this one shared data.
No.
But the way we make it shared is by using the once routine in the access class. That's why I said we encapsulate the shared access into a separate class.
Oh, so the once keyword can make it.
The once keyword is that, so the trick, there are really 2 tricks here. First trick is to say we are doing a once routine in the access class to say you can only create the bank data once because you're using a once routine. So you can see there's an invariant here to say if you try to call the data twice, it's going to give you the same objects. That's why it's singleton. You can see here, the equal sign here is a reference comparison. So if I try to call data twice in a row, I'm actually going to get the same objects rather than getting 2 objects. Without this once, if you simply say a do here, then this invariance will be violated. Because every time when you say create result.make, it's going to give you a new objects. But now, because we're using a once routine, it guarantees if you try to call this routine the second time, it's only going to give you the cache result for the very first call.
To what cache?
Cache. To store. Okay, to store something. Yes.
How long is the cache last?
Huh?
How long is the cache last?
Oh, actually, throughout the lifetime of your system.
It's like
Until your system crashes or until your
It
system
belongs
actually.
to like it go into a memory block and become part of
You
it.
can think of it will go to the heap. It's not going to the stack.
And wouldn't it be better if it like if you give it like an actual variable and then go into the other one?
No, actually, if you put in the actual variable, then there's no way to make sure. Well, there are two things here. The reason that we put this into a separate class is for the encapsulation purpose. It's a good design principle to make sure you encapsulate a particular purpose into a single class.
So after the first instance is run, then you could actually delete the code inside and just keep the result. It doesn't matter whether the code is going to touch again.
But actually, if you want to do this manually, without having this one keyword, you'll be actually a little bit ugly to actually maintain them. Right? It's not as good as this. You can try that and show it to me, assuming that convince me that worked. Okay, good. Okay, that's IFO here. So now, again, supplier, you got to make sure you have two classes. The supplier side, your data here, and you can see that we actually have bank access for both the create class here to make sure that no one can ever call create data.make. So this is what this restriction access is doing for you. Also, you cannot say data.make either. So this is also going to make sure only the data access can actually get access to it. Okay, so we have two restrictions here. Okay, you can actually put this into IFO, and then it will be very easy to make it compile and try with that.
Oh.
Okay, yeah.
So it means if in a class account, if I call the data
Make, it wouldn't compile.
Oh.
It's going to say that feature here is not exported to this class.
Oh. So where I can see there's not exported.
You can see that here, this feature here is only exported to bank data access. So the account is not included in the list.
Oh,
You see here? So feature here, and then you have a curly brace. You can put only one class name there, bank data access. If you here, you say bank data access, comma, and then account, that will work. But that's not something we want to do.
Oh.
Okay? Remember before, when we wanted to do the information hiding, we actually put a none here. That's actually one extreme case, which is to say we want to hide that particular feature completely from any potential clients. But here we are saying we're going to hide it from anyone else except for the bank data access. Okay? Right. Okay, that's just a way, one way of testing it. So you can see now I'm trying to test the singleton here. So now you can see now I create two accounts, and then one more thing to show you. So you can see that now that's a supplier side, and that's a client side. And now I'm going to briefly explain why we need the expanded class here. So you can see the lines across the arrows. That means this class here is expanded. The access class itself is expanded. So here, expanded class, data access here, you can see I actually can call the data access here without initializing the attribute, without initializing that local variable. Because remember from the previous lecture we said for the expanded type, you do not have to initialize them. They will be non-void by default. Okay? Okay, so you can see the only way we can get the data for the client is through the access. So you can see data access.data. Okay? And data access.data is going to call this once routine. For the very first time, it's going to go ahead and create the one and only data object in the universe. And the second time, when you're trying to, let's say, with another bank account clients, and then you're trying to call this data again, it's going to return back to you the object that's already cached in the memory. So let's have a look at this test case here. So we're saying we have two accounts for Bill and Steve, and now I simply say after I have initialized the two bank accounts, so that means I already have the data initialized to something, right? So now I'm going to do two checks. First of all, I'm trying to compare to see the shared data, the contents are consistent between the two objects. Okay? And in this comparison, I'm using reference comparison. I'm trying to check to see the objects, the data objects they refer to are the same objects. Okay? So would this one pass? Okay, would the second one pass? Okay, since we're implementing a single dependent, so you should really give a try and make sure both of them pass. Which one is stronger?
Second.
Second one is stronger because it's comparing to see if account one data is really referring to exactly the same objects as account two data, so it's stronger. If this is true, then this must be true. But the converse is not necessarily true. Sometimes you might have two distinct objects which actually got similar the same contents, but they are simply distinct objects. Okay, so now one more thing to show you the test. To say now, if I say account one data, so actually I got a data, and then I say set interest rate to be some value. Okay, so now I want to see once I do this change to the shared objects, now I want to query about the interest rate for the two accounts. Would they be the same? They should be the same, right? Because exactly shown in this diagram here, if I make any changes on this data here, using this axis here, anything that's changed here will be visible to all the accounts. Okay, so I think the best way for you to study this single dependent is to put the IFO code into IFO Studio and give it a try. And then think about the test cases and the architecture behind it. Okay? So, what about we take a 5 minutes break? Because the next lecture is going to be tough. 5 minutes.